Hi, my name is Megan Davis, and I'm going to be presenting the paper Forensic Investigation of Instant Messaging Services on Linux OS, Discord, and Slack as Case Studies. So this is just the table of contents. This is what we're going to be going over and discussing during the presentation. So to start with the introduction, instant messaging applications or IMAs have been around for quite a while. Most of us have probably interacted with them in some form or fashion, if we think about it, AOL or Skype. And then there are more recent IMAs such as Discord and Slack and Microsoft Teams. But while we have probably used these in our day-to-days, they probably have only recently become more popular in, offices and businesses. And what we can partially attribute that to is in 2019, COVID happened. And what we saw was a lot of businesses shifted from that in-office work where you had individuals, meeting in person, doing design together, all those kinds of things that were normally facilitated in a face-to-face component, shifted to an at-home model. And with that, a lot of the IMAs that perhaps companies were using might have been older or only had certain functionality. And so they shifted to newer IMAs or morely built out IMAs that had these additional functionalities to help facilitate this kind of new work model. And so we see that happen in the business side. But what we also see is that in the day-to-day interactions that you have with your friends and your family have also started to use IMAs. A lot of people perhaps before would get together to play board games on a Saturday night, but then when COVID had occurred and they had to, isolate, what instead they did is they started using like something like Discord to facilitate their game nights where they can share and play online and talk to each other. And so what we're really seeing is kind of this shift in this wider adoption to IMAs and becoming very integral in day-to-day society more than it was before. So when we talk about some of the IMAs, the two specific IMAs that we decided to focus on was Discord and Slack. So Discord being the first one. So for anyone unfamiliar with Discord, you can generally associate it in the sphere of hobbies and specifically video games. It's mostly associated with Twitch, which Twitch is a streaming service in which people can go on there and do videos and basically interact with live audiences in which they're probably playing a game or a board game or drawing and so on. And one of the things that Twitch has is integration with Discord. And this allows them to, do contests, to do giveaways, those kinds of things, and build bigger fan bases. And so a lot of people have started using Discord in response to that. Their last report was about 140 million active users. It does have multiple ways to engage with it, whether that be the mobile, the browser, or the desktop. We specifically focus on the desktop version that runs off the Electron framework. In addition to understanding Discord, we wanted to know how likely is it that a bad actor may use Discord. And so we did find a report from them that basically said in 2021 that they had removed thousands of servers. These included ones relating to child harm, cybercrime, doxing, any type of like violent or extremist content. So there were a number of bad actors on Discord. So here's an example of Discord for anyone who hasn't seen it. So what you can see here is on the left-hand side, we see a number of like little circles with icons. Those are the servers that you can join. So there can be servers situated around anything. This particular one that this user is in is related to biostudies. And as we can see in the left-hand dock, you also can see a number of different chat channels. So these are channels in which basically mostly text is done. And then at the very bottom, you can see voice channels where people are in voice, either streaming some kind of content or showing something and talking to each other. In the center, you see what is called study questions, which happens to be the chat channel this person is in. And you can see that they have different commentary going on. They have emoticons, people have posted YouTube videos and so on. And then in the right-hand side, you can see everyone who has joined the server and what kind of roles they have. So on the opposite end of the spectrum, if you view Discord as being primarily for gaming and kind of hobbies, is that you have Slack. So Slack caters to traditional businesses. You really can kind of view them as a competitor to Microsoft Teams. And they've basically situated themselves as basically an IMA for startups or smaller companies. They, like Discord, also have the mobile, desktop, or browser version, and they also run through the Electron framework. When we looked for instances in which that they had accounts or hate groups, we only found one report which said that they banned 27. And then they're a little bit on the smaller side compared to Discord when it comes to user count. Their last report that they had published was in 2019, where they reported they had about 12 million Slack users. So here's an example of what this looks like. Very similar to Discord if you look at the layout and design. On the left-hand column, you can see that there's one that says AI, AL, and AM. Basically, these are the equivalent of Discord servers. In Slack, they actually call them workspaces. So that is a differentiation in naming convention, but they function basically in the same way. On the left dock, we do see a number of chat channels where people can go ahead and post documents, etc. And then in the center, we see it's social media where there's a calendar event, we see some text documents and just some general information. Then on the right side, we see information specifically related to this particular channel, what's its topic, what's it's for, who all is in it, what kind of organization you're a part of. So then we want to go ahead and talk about our methodology. So our real goal here is to determine what we actually can see when we look at volatile memory for these applications. And so we found the best way was to create a set of use cases that cover basically a variety of scenarios. And we'll go into those more in depth in a few slides. But our main thing was we wanted to try and play out as many of these scenarios as we could to mimic everyday users interacting with the application. So we decided to boot up basically 3 machines using the same Ubuntu version, and we put them on the VMware workstation. And what we decided to do was limit the RAM to about 4 gigabytes. In addition to this, each of the machines got their own Gmail account, Discord account, and Slack account, just all of them have their own. And then on top of that, we did some additional file setup. We knew that we wanted to facilitate direct messages between users, as that's very common, as well as baseline server communications or workspace communications, depending on the application. We decided on just a base JPEG image, and then we also decided on a text document. These are all just pulled from the internet. It's just a basic image and a basic text document that was formatted, nothing too fancy. So with that, after we had all that preparation work done, what we decided to do was we decided to take snapshots of all of these. So after each event, which we'll go over, we took a snapshot and then we would analyze that snapshot. There are a set of sub snapshots where only perhaps 1 or 2 machines have actually had a snapshot occur after that event. We mostly did that due to application restraints. So if you think about perhaps a friend request. So in Discord, when you make a friend request from one user to another, that's a one-time event, right? You're not going to do it backwards. So what we ended up doing was just taking 1 or 2 snapshots of a subset of those machines when that occurred. So that's just something that is denoted and has happened. Once we had all those snapshots, we needed to analyze them. So we decided to use volatility 2.7. We specifically decided to limit to looking at the process IDs and specifically just dumping those. So we did use the Linux PS list to collect the Discord and Slack PIDs. From there, we used the Linux dump map. Inherently, it has the Z-read functionality where basically the way it functions is it will write zeros for pages not present. So we ran into an issue very early on in which we would actually write out just a lot of files that had actually no information in them, and it took, an hour and a half. So once we had understood what that was doing, we went ahead and changed that to just read. And what we did was we added a clause in there that if the value for that particular thing was none, then we went ahead and skipped it. And so that saved us a lot of time and wrote out the appropriate amount of files. So from there, once we actually did that, we had a subset of files that we had pulled, and we decided we wanted to even narrow that down even further. So we grepped on all the files to try and find which ones actually had this particular subset of words that's listed out here. So we decided to pick words that were specifically related to the applications we were looking at, and then kind of some common words like username and password. We thought this would be a good indicator of which files were actually worth looking at. Once we had done that, we decided to go ahead and use the string command. The reason for this is that there were a number of files in which there was just like a couple of characters or some kind of garbage like % signs and things that didn't actually have any contextual meaning. So we decided to limit basically words and find files that had 4 or more characters. Then just kind of as a catch-all, we did have some snapshots where we, for example, like quit the application, and obviously the PIDs do not exist in that scenario. And so we just used a WX hex editor where we actually went ahead and then just looked on certain keywords. So those were kind of the edge cases. So here's a full list of the snapshots. As mentioned previously, we do have a base snapshot, and then we did go ahead and do a bunch of snapshots for different Discord scenarios. You can see which accounts they're associated with. So we'll go over these more in depth in the Discord section. And then these are the Slack snapshots, which have a bit less, but we'll also talk about that when we get to the Slack section. So let's go ahead and talk about the Discord results. So the first process that we did with Discord was we decided to install it. So we just did a snap command to go ahead and install Discord onto each machine. After that occurred, we then took the snapshot. From here, we weren't able to find anything super Discord specific. The only reference we had was the actual snap command that was run as it was being executed. From there, we went ahead and logged in. So Discord's login process is fairly straightforward. What you do is each account, basically you made your login and password, but they didn't use any external login. So you basically just made a Discord specific account using your email and then chosen password. So what we did was we went ahead and logged in for each of the accounts with their email and password. And then we went ahead and did a snapshot after logging in. What we were able to find, you can see on the right-hand side part of it in the red box, you can see that we were able to find the login and password. As you can see, it's in a JSON type format. That's very common for basically everything that we find out of Discord and Slack. So unless otherwise mentioned, just assume that these were in a kind of key value pair from the JSON format. So we were able to find this, but in addition to that, we were also able to find the Discord ID associated with the account, if they had an avatar ID, channel IDs, if they were already perhaps associated with something, phone numbers, if you had a phone number tied to your account, last timestamp, tokens, game status. So for example, if you were playing a game, that would come up there, region, and then also geolocation. So all of these attributes that are associated with a particular account, we were able to find. The next thing we decided to do was we wanted each of the applications to go ahead, or each of the machines to actually go ahead and create a profile image, and then also to update their status message. And the status message is just a simple string. You can include emojis, but we just did a basic string. And what we did is then took a snapshot after this occurred. We were able to actually see the URL for where the avatar image was uploaded, and it is accessible, but we'll talk about that more in a couple of slides. In addition, we were able to find the status message, but interestingly enough, we were not able to find it within the context of it being in a JSON format. We were just able to find the exact phrase. So that was a slight deviation. After that, we went ahead and did friend requests and acceptance. So we had machine 1 basically be the default machine in which it would send a friend request to machine 2 and then machine 3, and then those would accept it. So the first snapshot was just the friend request being sent out from machine 1, and then the request accepted was from machine 2 and machine 3. What we were able to ascertain from this is that each of the users could only see their own data until they had interacted with another user. So once machine 1 had sent a friend request to machine 2, we were able to retrieve information regarding machine 2 from machine 1 snapshot. In addition, on machine 1, we were able to see success messages for sending out friend requests. So next we moved on to direct messaging. And here's actually a screenshot before we get kind of into it, just to give an example of what this looked like. So we had this test account called James K. And what we did was we contacted the other account that we made, Bones, and we went ahead and just put in some text, said we were sending a document, uploaded the document, and also a photo. And then below that, we did a GIF just to try and cover our basis with various types of interactions. So what we were able to find from that, once we had taken the snapshot between these two direct messages between these two machines, was we were able to find basically all the information related to the message. So we could see the time it was sent, we could see baseline attributes for it. And then in addition, we also found those text URLs and image URLs. So for those files that had been uploaded, we were able to see those. From this and from the avatar image that we had pulled previously, we were actually able to do a little bit of a deep dive and find out that these URLs follow a very similar format. So what we found was that it was either uploaded to cdn or media.discordapp.com, and then you could either have avatars or attachments, depending on what you were uploading. You would then have an ID, a file ID, and then the file name. And so you can see that link below, actually. And so you can see in this particular instance, we uploaded the Starship one-to-one message, which was our direct message. And actually, you can take that and you can put it in your browser, in any browser you want, and you can actually find that image. So what we had noticed with this is that despite the fact that this was a direct message between two particular accounts, as long as you have the URL, anyone can access this, regardless of whether you were participants in this or any other reason. So just the way that Discord tends to treat documents and uploads is that they're not tied to anything. You basically just need the link and you can access it. So once we had done that direct-to-direct messaging, we decided we wanted to create a server. So we went ahead and had machine one just create a baseline server. From there, we took the snapshot and we were able to find that within that it had server name, guild ID, any channels associated with it, if it had an icon. So the baseline information that we would expect to be able to see from a server. Here's the next step that we did in an image showing this. So we had a server where everyone joined. And so you can see here, once again, we mimicked a similar format where we sent some text. We added the text document, added an image, some emoticons and reactions. So once we had joined the server, we had the other machines join as well, and we were able to find quite a bit of information. This is the stuff that we had expected to find, very much mimics the direct messaging information. You can see on the right-hand side, we decided to highlight a little bit of this. And what we see here is that this was a GIF that we had uploaded. One of the users had uploaded this. So you can see when it was uploaded, you can see the timestamp of it. You can see, was it possibly edited? In addition to, you can see mentions and mention roles, attachments, embeds, all these different attributes that are particularly tied to the message. From here, also, we were able to find those image URLs and uploaded URLs, along with just a bunch of information regarding messages in general. So after that, we went to the assigned roles. So basically in Discord, you can create channels that are restricted, and they're restricted based on roles. So what we decided to do was have machine one and machine two get specific roles that could see a restricted channel, and then machine three had a role which could not. So what we were able to find here is that the message data exchanged in that secure channel, the two machines that were part of it could actually see and access, which makes sense. And then machine three could not. But the interesting piece about machine three was that it was able to see a reference to the channel name, but could not see any information within it. So here's an example of that. We had this officers only channel, captain medical were the first two that were added. And then lastly, we added communications. And so you can go ahead and see that once we did all of that, they were able to see that information. So machine three could see all that JSON data. Next, we decided to look at voice chat. One of the inherent qualities with Discord and beloved features of it is that you can actually go ahead and just have open voice channels where people can join and discuss and stream. And so we wanted to know, was there any information retained in that in volatile memory? So we had machine one and machine two go ahead and join voice chat, and we had machine three not, and then we took snapshots on all three. We were not able to find any information particularly referencing the users or the duration. The only line we found was just a baseline that seemed to indicate general voice channel and 2 users. But once again, there's no additional information or really any indication of who was in there, how long, what they were doing, or perhaps even talking about. Lastly, we went ahead and quit Discord. From here, we just did the WinHex edit to look at the information. We didn't find any new information, but we did see that most of the previous information was still retained in volatile memory, so that was there. Then we went on to Slack. So with Slack, a lot of the way that we did this was we tried to mimic Discord as much as possible. So we once again also did a snap command to install. All we found was references to the snap command. And then we went into a kind of combo. Whereas in Discord, you can go ahead and just log in and start doing direct messages or joining servers. In Slack, that's not how it functions. So when you go ahead and log in, it'll ask you immediately to either create a workspace or join a workspace. You can't really interact with anyone outside of that. So the way that we decided to approach this was we went ahead and did the login and create workspace on one machine, which is machine one, and then took a snapshot after. Then for machine two and machine three, we had them log in and then immediately join the workspace, and then we took snapshots. So the interesting bit about Slack is that it actually routes you through an external login server because you don't make a Slack specific login, you use like a Gmail account. And then because you're limited in direct messaging to workspaces only, you can't do any of the direct messaging that we tried to mimic in Discord. So with this, we were able to find information, once again, in that JSON format. We found emails, what time zone you were a part of, if you had any display information or statuses, along with what workspaces you were a part of, if there was a workspace invite. So the traditional information that we had found in Discord was basically mimicked in the same way. Then we went ahead and added a Giphy bot. One of the things we had done in Discord was we had GIF reactions. They're very common. And Slack does not have it natively. You have to go ahead and add a bot, which then will add that functionality. So we decided to go ahead and have Machine 1 add the bot. So we took a snapshot afterwards just to see what information existed. And we did find that it just has some baseline bot ID, name, profile. After that, we went ahead and updated all of their profiles. We had them set a image as well as a custom status. From here, we were able to find that information as well as how long the status had been active. So whether that was days or weeks or even just a couple of seconds, we were able to see that as well. From there, we did a direct chat message. So mimic the same thing we did in Discord. Now that we were in a workspace, as you can see here, we sent a image and a text document. From there, we were able to find the same amount of material: file uploads, message data, channel data, file links. We were able to see when it was sent, who it was sent by. You can see an example of that link down below. So we see the Enterprise Corp, which was the server, and then, the workspace, and then we see a bunch of information about the file. However, when we go to access this, we run into a problem. These are actually restricted. So unlike Discord, where as long as you had the link, you were able to access it, in Slack, that is incorrect. You have to be part of the workspace. They assign each file you upload to a specific workspace, so it is restricted. From there, we went ahead and had everyone join a general chat. From there, we just did the basic exchanging of messages, document uploads, etc. We were able to find the exact same things we were expecting to find, which was the timestamp, text, who authored it, their author ID, even an author link, and information about the author. Outside of that, we tried to mimic the private chat function. So one of the things that we ran into is that there are really no roles in Slack. And so instead, what we had to do was create a chat between two people, and then we could add additional people in. So we basically had a chat between Machine 1 and Machine 2. We sent some messages, and then we added Machine 3. We were unable to see any data on Machine 3 about the messages exchanged between Machine 1 and Machine 2, which was to be expected. But then once we had added Machine 3, we did have JSON message data for all of them. That's just clarified here as well. So after we had done that, we decided we wanted to go ahead and quit Slack. One of the things we were not able to mimic and should be pointed out is the voice chat option. So Slack natively, though, in the past couple of months, they started adding the voice chat option, but it's something that's like a premium tier. It's not really there by default unless you do like a trial. And so we decided that we didn't want to do the voice chat because it's not a inherently free feature of it. So we went ahead and quit Slack. As previously mentioned, we went ahead and just looked at that specific snapshot with a hex editor to see what information resided. We came to the same conclusions as we had with Discord, where there was no new data, but that previous data still remained. So in summary, if we kind of want to think about summarizing all of this up, is there are quite a lot of artifacts that are retained in volatile memory for these applications that are accessible. More specifically, we can see everything from avatar images to things about the servers, to emails, emojis, basically all the contextual information that you would be able to see if you logged into that Discord server or part of that Slack workspace. I think the main components to take out of this too is the way in which each of these respective IMAs treat the links that are uploaded, whether that be a file or whether that be an image or anything of that nature, where Discord does not restrict anything. Whether you are part of that conversation or not does not matter. You can access it regardless. And so that's something that's very different from Slack, where Slack restricts it based on the workspace. So you have to be part of that workspace, so they have an extra layer of security, whereas Discord does not. So when it came to future work and really the avenues of which we could go with this, I mean, both of these applications have a ton of additional functionality that we didn't test. So we could go ahead and test things like deleting messages, adding messages that were then deleted by administrators. We could look at editing messages, pinned messages. A big thing too is that we didn't really look at data after prolonged usage. So for example, if you had someone who used the app for 5 minutes, how does that differ from someone who's used it for weeks at a time and what's still there? In addition, looking at probably bots or additional file types. And then lastly, what would be really big and really helpful to this is while we manually with the help of some commands, looked at all this data, creating a framework which could parse that JSON data, reconstruct it in a way that's easy to access and understand, and then kind of streamline the whole process. So thank you for listening, and please let me know if you have any questions.